Hi, my name's Freddie Meyers and I'm the musical director of Bandwidth. My composition, Night Meeting, was written for violin and cor anglais, both in different temporalities. In this video, I'll talk about how I created a patch using the software Max to generate two temporal spaces across the internet.
1, 2,
3.
Since the beginning of the COVID-19 pandemic, I've been increasingly interested in using canons in my music, as the period of lockdown has felt both repetitive and timeless. Duplicating musical material in a canon creates a similar sense of temporal displacement, which I found particularly captivating. This process began with two canons for solo violin and tape delay, which was simple enough to achieve using Ableton or Logic. However, this evolved to a third canon by prolation, as well as Night Meeting, which both required a real-time audio speed shift that changed both the pitch and the duration. Most of us are familiar with time-stretching audio from vinyl record players. Records are made by carving the disc at a specific speed. When you play a record back at the correct speed, you hear a reproduction of the recorded sound. However, when the disc is rotated at a different speed to the recording speed, the pitch and the duration of the recording changes. The principle is the same in the digital world, with the sample rate determining the speed of the clip in a digital audio buffer. By playing back digital audio clips at a slower speed, we can create a prolation canon effect where the same part is played slower or faster. Doing this in post is a simple process, however it's more complex when needed to be done live. In order to record into a digital buffer, the sample rate must be set. We can't play back the original audio at a different speed without altering the sample size of the recording buffer. Therefore, a buffer must stop recording before it can play back at a different speed. My solution to this problem was to create a Max patch that uses very small buffers. With a buffer size of 1 second, the audio is only recorded for 1 second. The input is then transferred to the next buffer. When we need to play the audio back at a different speed, we start with the first buffer, which is no longer being recorded into. There will always be a short delay that is the length of one buffer size between the recording and the playback. In order to avoid pops, which is the annoying sound when an audio file stops abruptly, in my Max patch I have a second set of buffers that are displaced by half the buffer size. When playing back the audio, I crossfade between these two buffers so there are no hard joins between the clips. With this done, the rest of the Max patch is fairly simple to create. The recording session was run through Source Connect Now, an internet-based audio application. In Max, there is a built-in monitor which we use when we're not playing so that we can hear each other normally. By pressing the start button, the project is triggered. This plays a recorded countdown. 5, 4, 3, 2, 1. When the file finishes, this turns on the recording to the buffers. In Night Meeting, the core is delayed by 1.5 seconds, while the violin is delayed by 2 seconds. After these respective times have elapsed, the playback from the buffers are triggered, 80% speed for the core and 75% for the violin. The delayed core audio is then sent through the violin headphones on my end, while the delayed violin is sent through Source Connect. The patch is also built with a stop button that when pressed fades out the delayed audio and turns back on the monitor. I hope you enjoyed this video. It's slightly different from the sort of stuff that we normally do with Bandwidth, but it hopefully gives you an insight into the more technical aspects of making music on the internet. If you'd like to hear more about us, please subscribe to keep updated with all of our latest performances.